LinkedIn. I'm not sure, and it sort of closed down on me. So,
Hmm.
all right, it says we're streaming. It says sending data. Facebook, LinkedIn. It is 5 o'clock. Let me just verify. I love technology, but I always there it is. Join now. I got the you got the notification
Yeah,
too. I love it.
yeah.
Technology at its best. All right, everybody out there, and this is Technical Tuesday. I call it, you know what? I tell you what, Russ, anymore, it's going to be Power Tie Tuesday.
No.
And we got David
All right.
Rodriguez already in the house. Thank you, David, for that confirmation out there on YouTube land. We got LinkedIn up and we got Facebook up. Today is an awesome topic. And Russ and I, you have been talking about this for a while, about going live, about talking about how important it is to getting into the into that safe outside of that arc flash boundary. So first of all, welcome. Thank you for joining me, Russ. And why don't you give us a little bit of your back? Because I'm sure nobody out there has seen you yet on this channel, at least. So what I'd love to, why don't you give us your background and tell us a little bit who you are and where you've been, what you're doing.
Sure. Thank you, Tom. Thank you for this opportunity. Um, Again, my name's Russ Safreed. My background, I'm an electrical engineer, graduated from West Virginia Institute of Technology. Um, Worked most, good part of my career out in industry. So I've been worked for Union Carbide for several years as a power distribution engineer there. Worked for a electrical contractor for a while, actually, getting some contract experience. I've worked for DuPont and for an engineering firm for a while doing design engineering. And then about 10 years ago or so, I had the opportunity to join up in a business, Martech Limited, who uh, I happen to know the gentleman very well that had invented what's commonly been learned as the chicken switch. And you'll see more about that here in this presentation. And he and I partnered up and kind of grew that company, Martech, for several years. And then here, about 3 years ago, we were acquired by CBS ArcSafe. And he retired, and I stayed behind. And I now run the West Virginia location where we design and build remote switching devices and racking devices.
That's pretty cool. I'll never forget the first time you and I met. It was at the electrical safety workshop.
Right?
And I can't remember
That's
who
right.
I was talking to said, and I told them I'm from West Virginia. They said, "Oh, Russ Safereed's from West Virginia." And I'm like,
Yeah.
"Really?" And then we
Yeah.
find out that you're from right here in Weirton, West Virginia, and you're down now in
Charleston.
Charleston. Yeah,
Yes, sir.
yeah, that's awesome. So I said, "Small world," and I just love the name, the Chicken Switch. Who come up with
Well,
that?
thank you.
Who come up with it?
Charlie McClung did. He was the one that started Martech, and that was the first device that was his idea, the first
Is that right?
device he started building. And he named it that because he was the person, he was actually come up as an electrician, and he was the guy operating the equipment. And he also understood the hazards that he was facing when he went up through there. And he said every time you went to switch something, you wondered if it was going to be your last time.
Oh
And you
wow.
kind of, when you understand the hazard, you're kind of scared to do it. And
Yeah,
I
that's
think that's
exactly.
where the name come from. Yeah.
Yeah, that's exactly right. So look at this. We got Ryan Jackson, David Rodriguez. We got Felix Sandoval. I thought you were supposed to be working, buddy. So I don't know, man. I don't know how you're doing it, but Felix is down there in Columbia, not South Carolina. And then we've got Japan, Tamaki. Thank you for joining us, Frederick Fowler. And Frederick says we use them every day. Awesome. That means Frederick is getting out of that arc flash boundary. So hopefully we can add some information for you, Frederick, today. So hopefully you'll get something out of today's program because we're talking about adding distance, getting outside of that arc flash boundary. And Russ, I know from a safe work practices perspective, we're going to have this discussion as we move forward, but there's a lot of things in 70E that tells you when you either do have to dress or don't have to dress. But I always say safety is like an onion. And I know it's probably an overused example, right? But
Mhm.
um, the layers of safety, in my opinion, you have the steps of the meetings and getting your head in the game and all these different things, and you have like for example, GFCI protection, that's your last resort, but you have all of these layers of safety. So even when you think everything there, nothing can go wrong, it never hurts to still get outside of that arc flash boundary. Even
That's correct. Yes. Yes. And really, and you'll learn as we get through this, I mean, the number one way to protect yourself is to get away from it. It just eliminates a lot of issues. If you're able to get away from it, you're not going to get hurt.
That's exactly right. So the first step out of all of in this before I go into anything, out on CBS ArcSafe's website, your mission statement. I always like to understand organizations from regard to their, you have your mission and your strategies and things like that. This was a sentence in your mission statement, CBS ArcSafe's mission statement. It says, we believe that our extensive line of arc flash mitigation equipment, in conjunction with training and awareness, has rendered arc flash injuries not only avoidable, but unacceptable in today's workplace. And Russ, I say that in regard to shock protection, and I loved this sentence in your statement because it really, it's such a fact that we have technology today, not only on the shock side of the business, but in the arc flash as well. I mean, we can reduce the incident energy if you have to do justified energized work. We can get you outside the arc flash boundary. If you leverage technology, it's unacceptable.
Right. And I was fortunate enough to start out with a few companies there that had that belief that every injury is avoidable, and that's what they strove for, and provided some, I guess, good training later in my career, and to realize that whether it's stuff you do in personal life or whether it's at work, if you think things through and you do the right thing, every injury is avoidable.
Yeah, and when you think about, you worked for DuPont, right? And and DuPont's a good customer of ours, and other petrochem facilities as well. And that petro industry, in general, I think, get it with regard to electrical safety. I mean, we've been working with individuals like DuPont and others about incident energy and like zone selective interlocking on circuit breaker technologies to protect equipment and mitigate damage for ages, even before 70E or the National Electrical Code recognized any of this, because they choose to go above and beyond, because to your point, they recognize there are certain companies out there that recognize it's beneficial to not only the employee, but their business in general.
Mm-hmm. Right.
All right, so I wanted to make sure that I touched on that, because I read that and it caught my eye, and I think it resonates with things that I've said on this channel. And we've got Steve Cavaleris from New York. So we got New York, we got Frederick Fowler, Felix Sandoval. He got a signal. Oh my goodness, thank God you got a signal. The arc flash boundary, Russ, to figure this out. I mean, if you want to get outside of the arc flash boundary, you got to know what those boundaries are within 70E.
That's correct.
So 70E gives us some definitions in Article 100, and I've got the 2021 version. So some of the language that is in here, and I got to keep checking, because these NFPA panels love to change stuff on you between editions, and sometimes it's a subtle change but means a big deal. So they've got three, and I'm going to talk about right now, we have the limited approach and restricted approach. And the reason I bring those up is because there's a difference between an arc flash boundary and a shock boundary. Usually I'm pretty far away from the equipment, usually, because in some cases the arc flash boundary the arc flash boundary may be smaller than the restricted approach boundary, right? It all depends on the calculation. So, but these two are focused on shock. The first one is relatively close to the exposed conductors, and the second one is a little bit further away. And what we do is we sort of tell you, when I say we, 70E sort of tells you who can be in each of these boundaries, within each of these boundaries, and then what training level, what qualifications, how you treat those individuals, et cetera, that are in those boundaries. So what we're talking about is getting outside of the arc flash boundary, not necessarily what you're doing with regard to the restricted approach or limited approach boundaries. So, and one of the things to remember from a hazard perspective, 110.4C and 130.1. So 110.4 is your energized work, and C talks about energized. I'm getting old. Energized electrical conductors. So it's equipment operating less than 50 volts. Energized electrical conductors, circuit parts that operate at less than 50 volts shall not be required to be de-energized where the capacity of the source and any overcurrent protection between the energy source and the worker are considered, and it is determined that there will be no increased exposure to electrical burns or to explosion due to electric arcs. So I don't have an arc flash hazard at less than 50 volts, and I don't have a shock hazard at less than 50 volts. Robert's saying 110.6 qualified person. Robert is Robert teaches this stuff. So, and Ryan Jackson teaches this stuff. So this is the thing, Russ, you got to like sharpen your pencil with these guys.
Yeah.
Or here's what I always say, Russ, whenever I misspeak sometimes, like if I say, oh, this is the way it is, and then Robert or someone will say, oh, no, Tom, I'll say, that was a quiz. Okay.
Yeah.
That was a quiz. Yeah, and 110.6 speaks to training. And I think, and I didn't put it in here, but Robert brings up a good point. That 110.6, talking about training and the educated person, is important when especially when you're talking about some of the resources that we're going to be talking about today, right? Because you've got to understand how to use them. Now, is that something like, does CBS ArcSafe do training on this equipment?
We do. Yes. Yep. We offer training. When you buy from us, you can get, training comes along with that.
Oh, it comes. Oh, great. Excellent. Excellent. And now, so Ryan points out, you can have an arc flash hazard. So let's think about that. Less than 50 volts. Can I have an arc flash? And the fact is, yes. But the arc flash boundaries are so small and the energy is so low. I can draw a spark and say that was an arc flash, so to speak, because it's an arc. It may not have the ability to get a longer distance. I may not have to worry about being 6 feet away. It could be inches. My arc flash boundary could actually be inches. And we're going to talk about what an arc flash boundary means here in a second. So there's your restricted space. I'm not like Ryan and the IAEI or Mike Holt and those guys who have very intensive and capabilities in graphics. So that's your limited space boundaries. There's your reference 130.4C, talks about exposed electrical conductors and circuit parts. And it talks about the difference between a qualified and unqualified, who has the responsibilities, what their responsibilities are. Then you get into the limited space, so that boundary is a little bit further. Now you can bring somebody into this space who you have to keep an eye on. It's sort of like anytime I'm on a job site. It's like, where's Tom? What's he doing? And what's he doing over there? Keep your hands in your pocket. Put the little leash on him. Now the arc flash boundary. Now this is, I think, where we're talking about. This is where the rubber meets the road in this discussion. So what we do is we run a calculation, and we calculate typically the working distance, 18 inches, what your incident energy values are, and that's arm's length away from the exposed conductors, right? But to establish the arc flash boundary, it's an iterative process of putting in different distances into the calculations for incident energy until you get to 1.2 calories. So what that does is if I look at what my incident energy is at 18 inches, I will keep increasing my arc flash boundary to get to 1.2. But if at 18 inches my incident energy calculation is like 0.5, then my arc flash boundary has to get a little closer, right? Because now at 18 inches I'm at less than 1.2. So to get a higher incident energy, I have to get closer and closer to the arc. So there could be some cases where my arc flash boundary is less than 18 inches. And now I'm worried about my gloves as opposed to the whole arc flash. I still have my face shields and things like that I dress for. But my arc flash boundary could be smaller. Okay,
Yeah, so we're trying to get away from it to where we get down to below 1.2
right,
is really what we're trying to do. Right.
exactly.
And as you move away from it, I believe that number changes by pretty quick. It's like by the square or something. So, every time you double the distance, you're cutting that number way down pretty quick.
Yeah,
So,
exactly. Yeah, distance is your friend in all of this. And then now to determine the incident energy, I can run a calculation, and I use IEEE 1584. And on this channel, we have done that. We've already gone through short circuit calculations, and we've calculated incident energy and arcing currents, all of that good stuff. We talked about the clearing times and how to determine incident energy. So I can do that by the math, or 130.7 in the National Electrical, or in the NFPA 70E. 130.7 is titled personal and other protective equipment. And if you look at 130.7 Charlie 15A, this is what everybody lovingly refers to as the table method. So the table method basically gives you this is that area, Russ, where you'll get into a lot of debates with engineers, right? We say, well, the table method, it doesn't consider arcing current and all this other good stuff. And they lose sight of the fact that the table method is a means in an unlabeled environment. You worked at DuPont, you were probably in a labeled environment, right?
That's correct. Yes, sir.
When you have an unlabeled environment, what does the electrical worker do to figure out what they dress and how they dress? And they'll use 130.7C. And what this table does is it basically gives you all the different types of equipment and some parameters: voltage, available fault current, and what is the upstream overcurrent device. And it tells you the arc flash PPE category, so it tells you how to dress. And then the next column is the arc flash boundary. So I'll give you an example: a panel board. A panel board or other equipment rated greater than 240 volts and up to 600 volts. So take a 480 volt panel board. And if you have 25,000 amps of bolted fault current or less, and you are downstream of a molded case circuit breaker or current limiting fuse, and an 18-inch working distance, you're in a PPE category 2, and your arc flash boundary is 3 foot. So you would draw a line, you would get those rubber or those tapes and mark out your 3 foot around your work area and use this table. And Robert is a great straight man. He brings up the condition of maintenance, and we do have a place in this discussion where we talk specifically about that. But right now, this is how we're establishing the arc flash boundary. We're doing a calculation, or we're using the table method. Right? That's about it. I mean, that's right. That's it in a nutshell. And for the most part, what you and I are familiar with is if those arc flash boundaries that exceed the restricted and prohibited approach boundaries, and those are the cases, those are, where you're really going to see a value of getting out of in front of the equipment. Medium voltage application, 480, 600 volt applications. Those are the areas where you say, listen, I'm going to get out in front of that piece of equipment. We don't have umbilical cords and overcurrent device, or unless you do, Russ, I don't know. Tell me, have you ever created something that goes on the front of a 120 volt, like a panel board that operates at 12240, that operates a little 20 amp or a 40 amp breaker?
I think we've built stuff that operates pretty small breakers. I'm not going to say they operate, down to the hose
Right.
house type ones, but yeah, we build. If you have a breaker that needs switched, we're probably likely to not say we can't do it. You know.
I tell you what,
Yeah.
and so this comes from a guy who builds race cars and welds and does all this other great stuff. There's nothing you can't figure out, right?
Yeah.
That's the truth. Now this is what we're talking about. So this is what if when you think about that arc flash boundary or an arc flash zone, we're going to do that calculation. So if you're looking at that gold box of equipment that you're going to be working on, if it's exposed energized parts, you calculate what that boundary is, and you know you would typically want to see a physical boundary. I mean, if you're going to do work, you always see those taped ribbons, and it never hurts to go a little bit further than what you calculate, right? If it's 3 foot, you don't get a ruler out and start measuring 3 foot. You go maybe 6 foot away and you start putting your boundaries up for arc flash. You say, look, stay the further away you can keep people, the better off you are. And CBS ArcSafe says Russ is right. If you have a breaker that needs switched, we can do it. I love it. I love it. All right, and this is the shock protection boundary, probably a little bit out of order, but that's okay. Hey, this is the way we roll here when we're live. You've got that limited approach boundary and the restricted approach boundary. These are the things that we talked about, and if you look at the voltages, this is all about shock. In this here talks about when you have conductors that are exposed that are moving, you have to get further away. Like if you have power line conductors and things that are moving. But what we're talking about is that arc flash boundary, getting out of that arc flash zone. But in reality, Russ, if there are other things in and around this, that's not the only reason really to use this remote. Is not just arc flash. I guess you could make an argument that if you have something where you have exposed parts or whatever in and around that area, you may want to get that person out of that zone for other reasons.
That's right.
Yeah, you may have an area that's like a hazardous, or there may be an area that has an environmental condition that you don't want your worker to be in.
That's right.
Yeah,
Yep.
that just dawned on me. No, I'm
Yep.
pretty good, huh?
Yeah. Yeah.
I'm learning.
Yeah.
I'm learning.
I remember energizing a motor one time at DuPont, and there was a capacitor bank on it, which decided it was going to let go as soon as it energized. So that could be a good example of something you'd want to be out of the way of, possibly. You just never know when something like that might fail. I mean,
Yeah, it might
fireball
not be.
rolling out. Yeah.
It might not be that specific piece of equipment that you're focused on that you've got to worry about. It might be some ancillary piece of equipment.
Right.
Yeah, never thought about that. So there are multiple reasons to get out of these different boundaries, and you may not even have to sit down and calculate those boundaries. You might just say, look, there's a wall, there's a door, I'm going to get on the other side of that wall and that door.
Right. Just makes sense to get away from it. If you got the equipment there already,
Absolutely.
get away from it.
Absolutely. Okay, so let's talk about the arc flash a little bit. An arc flash event, you got the light, the heat, and I think you and I were talking about this, and you raised the valid point that there's shrapnel too.
Mm-hmm.
You're going to have, depends on the magnitude of the event. In fact, the nuclear industry is studying this right now. They call them HEAF events. A high energy arc flash, HEAF. And if you Google that or search it, I keep saying Google it. I mean, it's a brand. Whatever search engine that you use, if you go out and search the web for it, you'll find there's a lot of research. And since it's the Nuclear Regulatory Commission, the reports are free because it's a Nuclear Regulatory Commission. It's a government type of thing. So they are concerned about taking out all of the equipment around it because that arc flash boundary can be so large. and that's a concern. So, and this just gets that worker out of that whole area.
Right. Yeah, there can be shrapnel flying. I mean, I think I mentioned to you the other day that I think the first time I met Hugh Hoagland, for the guys that know him, he, he's a PPE guy. At the first presentation I saw him give, he said that first thing you want to do in any of these situations is figure out how to get away from it.
Yeah.
He said that's your number one protection, is to get away from it. And then, and of course, there's going to be cases where maybe you can't do that, and then the PPE comes into play, but you can't guarantee the PPE is going to protect you, because maybe there's flying shrapnel or a door comes off.
Yep.
And sometimes when those doors come off, I mean, I've seen a door come off a piece of switchgear one time that drove it halfway through a sheet of 3/4 inch plywood. We had a plywood wall built in front of it, a couple feet in front of it, and amazing.
Whoop, hold on. Sorry about that.
Yeah.
This is an example to exactly what you were saying. So if you look, look right up at the top. Okay, at the top of that wireway cover is on, it's intact. And after this event, which they didn't anticipate this, that wireway cover is gone. So I look at that and I think about, all the different aspects of electrical safety. And to your point, that wireway was not anticipated on coming off. And you know what pushed it off? I used to think that the energy went up through the conduit and pushed it out. At least that's how I used to tell people. Until I talked to Vince Saperita and Tim Sternko, who were in the room when this happened, and they said, "No, that's not the way it went." He says the reason that thing popped off was because of the magnetic forces with the wire, and they bounce around in there, and it was strong enough to blow that wireway off. So you wear your helmet and you wear all your safety gear, but yet you can still get seriously injured even if you're wearing your PPE.
Right.
Big misconception. Okay, so we know how we established the arc flash boundary. We know that arc flash events can be very severe, right? Now we're going to get into how do you get outside of that boundary, and when things may occur as opposed to when they may not, right? And we're going to get into that discussion that Robert brought up about condition of maintenance and all this other good stuff. Robert says he had one instance where the arc occurred 15 feet away from the disconnect along the bus. So there's another issue if you think about it. You have various conditions that could occur where you might have an upstream piece of equipment fail because maybe it was not rated correctly or applied correctly. When we do a lot of educating about short circuit current ratings and interrupting ratings. If you exceed the short circuit current rating of an upstream piece of equipment, the current passing through it, it becomes an unintended rapid disassembly in the field.
Yeah. Yep.
And there's your arc flash boundary. Go ahead.
Yep.
Oh.
Once you let the smoke out, you got to send it back to the factory to get it fixed.
Yeah, and smoke is expensive. I don't know about you guys. I don't know where you source your smoke from, but I tell you what, it's hard to come by. And I don't think it's because of COVID either. All right. So do you want to speak to this one?
Yeah, well, this is a ANSI chart. It comes out of ANSI, I believe. And I know in the chemical industry, we use this a lot. And it's kind of talking about the hierarchy of how you protect something from a safety standpoint. And what they're saying is upside down triangle here. So anything you can do at the top does the best to eliminate something from happening. I say eliminate, that's not right. Does the best to prevent an injury, or in the case of chemicals, maybe a chemical release or something like that. And the number one thing is can you just remove the hazard? So, for example, at some point in time, maybe an engineering firm, when they're designing something, they may say, "Gee, this is a big arc flash hazard. Is there a way to do this without electricity?
Right.
If we could use another source somehow to accomplish the same thing, we just eliminate the arc flash hazard." Of course, that could maybe bring up a different hazard, but
Yeah.
but you got to look at that. And in a chemical industry world, they may be looking at different chemicals that they're using to make a final product with. Can we use a different chemical to make this product instead of this really hazardous one? The next thing is substitution. Again, that's using something different. I guess that ties into what I just said. Then there are ways to engineering controls. For example, maybe you're designing some piece of equipment, a lathe or something, and you put sensors on there that a wall sensor, that if somebody breaks that sensor, it shuts the machine off.
Mm-hmm.
So you do things like that to protect people, and that does, that's not as good as eliminating that milling machine altogether, but it does help minimize the chance of someone getting hurt. And then there's administrative controls, which is usually procedures and stuff fall into those. You can tell somebody you can't get within 2 feet of this, and you can make that a rule in your plant. But if someone doesn't follow it, then it doesn't do a good job. And that's why you're getting down here near the bottom of the triangle. And of course, PPE, although you can't eliminate it altogether, it's one of those things that companies look at if they want to, you don't want to rely on PPE to be all your protection. So you try to come up with things further up in that triangle. And getting away from the equipment, doing remote operation, getting outside that arc flash boundary, you can make arguments it falls somewhere in that engineering controls, administrative controls category. You're engineering away. And in some cases, as you'll see here, we'll show, you can engineer in a way where it's actually a permanent installation where the person doesn't have any choice but use it. In some cases, you're still relying on someone using that equipment to get away from it. But anyhow, that's what this hierarchy of controls is about. And I think you'll find this triangle in 70E now.
Yeah, well, what's funny?
Somewhere.
When you were, and it just dawned on me when I was looking at this, and I realized that in the last version of 70E, they have the triangle right here on the cover.
There you go.
Okay. Yep. And it doesn't show very well because of my green screen, but I remember Jimmy Dollard and a few others commenting that this triangle, it has the same order, elimination, substitution, but on this, elimination is up here at the top, and it's the peak of the triangle, and PPE is down here at the bottom, and it's the longest portion. So it's like the triangle's upside down, but they also flip the words.
Probably they've done it that way, probably because the PPE in some ways is the easiest thing to do. Just give someone a suit and say wear it all the time. The elimination part doesn't happen very often. It's not too many occasions you have a situation where you can say, "Gee, we'll just do this without electricity." Yeah. But maybe that's why they put it in there that way.
Yeah, and so another good example for substitution, I think, is like maybe going to just a whole different topic. Like LED lighting. I've heard of LED lighting has longer time periods between doing that. You have to put somebody in a lift. So if you have to put somebody in a lift to change light bulbs, like say once a year, if you change the light fixture to something that you have to do that same action maybe once every 8 years, you've done a substitution that increases safety because he's not in that lift or she's not in that lift as often.
Exactly.
So now the other thing, and I don't know, maybe overusing this in my day-to-day vocabulary, but risk is a combination of likelihood and severity, right? So, and we accept risk every day. You know this when you get on when you get on a track, when you're going to race, right? Or you get on a bike, that you're going to go. How fast do you have the bikes that go? How fast does a bike go on a track?
My nephew down there doing 160.
So 160 mile an hour on a motorcycle, right?
Right.
Severity and risk. The risk is high because the likelihood, you try to reduce likelihood. You can't change if you're going 160 mile an hour on a motorcycle. You're not going to change severity, okay, right? At
Right.
160 mile an hour. But what you try to do is reduce the likelihood by all of the checks and balances that you put in place for
Mhm.
safety. And your nephew's wearing personal protective equipment,
That's
but
right.
you don't want to hit the ground at 160 mile an hour, even whether you have personal protective equipment or not, right?
Right.
You want to avoid that. Well, you can take a look at this whole scenario the same way, and you say, what is my risk? And 70E tells us we have to do a risk assessment for shock and arc flash. So we're going to have to understand our boundaries. We're going to have to understand severity, and then likelihood. We can do things with barriers and things like that, but there's a lot of times you can't control the likelihood of something. So I agree with you. I was curious to see where you were going to go with this, and I agree. It can be in engineering controls and it can be in administrative controls, because I've seen tools. I was with a customer of ours, large industrial, and they have our communicating systems in place. And we're standing there, and they said they were going to open a breaker, and they're getting all suited up. And I was like, "Why are you doing? What's he going to do?" And he's like, "Oh, he's going to open that breaker." So and they were showing me the personal protective equipment. I'm like, "Well, why don't we just do it from the computer?"
Right.
And then they were
That's
like,
right.
"Oh,
Yeah.
I didn't. Can we do that?" And I'm like, "Well, you bought the system, and we put the
Mm.
capabilities in there."
Right.
And I've seen hot sticks leaning up against the post and them not using it, and so it goes into the safe work practices. So there is some administrative controls associated with all of this. We got to get people using this technology,
Right.
and then, I've seen this label in various facilities, or they say it exceeds the max personal protective equipment. And we could have a debate. And I'm sure if Scott Margolin was here, because we did a program with Scott on personal protective equipment, he could probably educate us that they have moon suits that you can go high, very high in incident energy. And you and I, Russ,
Mhm.
I don't want to have to put on that moon suit that even meets that higher incident energy, right?
Right.
You don't want to be around it. Unless you're your nephew and you want to get on a 160 mile an hour
Well,
motorcycle.
yeah.
So the only solution in some of these cases, now, if you have to do justified energized work, that's a whole different picture, right?
Right.
You're not trying to establish an electrically safe work condition. So the technologies of getting outside of the arc flash boundary for remote either opening or closing, that's really not associated with justified energized work.
Right. That's correct. Yeah, most everything we're talking about today has to do with opening, closing, and racking.
Right.
Right.
And we got Moises Fuentes out there. And Robert from Omaha says these are not just controls, but control methods. And that's true. Let me. Oh, we got some comments. Frederick Fowler, especially when all bolts and screws are not in place on the gear. Yeah, so there, with these condition of maintenance, and that's we're going to be talking about that whole topic of condition and maintenance. It's important to understand. And then look, there it is,
There it
operating
is. Yeah.
condition. It's almost as if I knew, right? But I didn't,
Yeah.
because this PowerPoint's changed up until 5 minutes before we started. So
Right.
these are where we find that in 70E that talks about safe work practices, and they these are all of the conditions
I
properly.
think it. I think it says that if you meet all these normal operating conditions, then it's safe to operate it without protection. I believe. Is that correct?
Yeah, 130 dot. And you had
And
referenced 130.1, or I'm not sure, and it could be. Remember, we got two different. We got to worry about the versions. Yeah, There it is.
And
So, and it's the work involved. So they moved that to, I think, 130.2. Yeah.
in the the electrical safety professionals out there, I guess we'll call them, that live this stuff and worked out in these plants, realize that if you look down through that list, it would be a rare occasion that you can say with confidence that you meet all those.
Yeah.
I
I mean,
mean,
you can look and say, well, yeah, my doors are closed and secured.
yeah.
But
Was it
how do
properly
you
maintained? Yeah. How do I know?
how do
I
you
work at
know?
DuPont. Yeah. I've been there 6 months and I walk up and I say, has this really been properly maintained? And you just don't know.
Right. And then you look and say, now we're trying to take steps to increase the awareness. Like, for example, we just released our power defense circuit breakers, and on the power defense circuit breaker, we're putting health. And what that does for you is it gives you an indication how many times was it cycled, open and closed? How often has it hit opened because of fault currents or overload currents? What's the temperature of the environment had been like? So you can get data on this, but that's not on every application out there. And that tells you the overcurrent device. It doesn't necessarily talk to you about the equipment and the enclosure and everything else associated with it.
That's right.
So it's almost as if, I used to hunt when I was a kid. I remember my dad telling me, you treat every gun as if it's loaded, and you always check it regardless of what anybody told you, because you've got to make an assumption from a safety perspective. And in many cases, it's better just to say, look, I looked at my records. I looked at the health on the breaker. I looked at the equipment, looks in good condition. I looked at the available fault current that I estimated the fault current. It seems to be less than the short circuit current rating. I'm going to get outside the arc flash boundary anyway, right? Or I'm still going to address. I just had this discussion. There was a customer who called me about. He called me about a contractor that he had, who was going to. The way he described it. He says it was a new installation, and he said that they were going to close a breaker, 3,000 amp power circuit breaker. And he says the contractor said he wanted to put his 40 cal outfit on to close the breaker. And the other contractor who called me said, that's ridiculous because it's a brand new installation. And he says it's brand new, so there's don't have to worry about the condition of maintenance and all this other good stuff. And he goes. He said he was going to go to the truck to get his outfit. He says, and I told him, you go ahead out to the truck. I'm going to just close it. And he says, and I closed it. He goes, but he told me, don't do anything until I get out of the room. And he grabbed his tools and he left. And I explained to him that, especially on new equipment, even relatively new equipment, that's not a normal operation. You just installed something.
Right. It was just brand new built. And I think it's been years ago since I've seen it, but I think, that first year of operation is one of your highest probabilities of having a problem. Yeah.
You think about your plant is probably changing, right? You don't know if you cause an issue even somewhere else. Like you said, ancillary equipment. You may have this piece of equipment and you turn something on and off, that all of a sudden the equipment over here ends up in a compromised position because you're changing your power distribution system. It's you gotta make sure that you understand the condition of not just this equipment but other ancillary devices. To your point, those capacitors went right. It might not be directly related to what you're looking at. Okay. Robert of Omaha, he brings up a good point. There is a table, 130.5 estimate of the likelihood of occurrence of an arc flash incident for AC and DC systems. Okay. And there's a task, there's equipment condition, and then there's likelihood of occurrence. If you look at Operation of a circuit breaker or switch the first time after installation or completion of maintenance in the equipment, any condition, and yes, there's a likelihood of occurrence. Insertion or removal of plug-in devices, the busway, examination of insulated cable. So it goes down through all of these lists, examining voltage transformer or conductor, control power transformer compartments. It gives you all of these conditions, and it basically tries to give you an estimate of, is there a likelihood? And then what you have to do is figure out severity, which is your arc flash calculations. And then obviously voltage if it's 50 volts or more. Now, insertion or removal of revenue, insertion or removal of covers for DC systems, opening voltage transformers, operation of a circuit breaker switch contactor or starter, voltage testing on individual battery cells, opening a panel door, hinge door, or cover to access dead front. So if there's a dead front involved, so there's a lot of things in here that help you understand about determining the likelihood of the occurrence. And to your point, Russ, I'd rather be out. I mean, if I have the technology, there's no even, I shouldn't even have to try to estimate this, because if I have the technology that gets me out in front of it, just use it. And then you don't even have to worry about trying to read the table and try to figure that out.
That's right.
How much time do you think it takes to put one of these devices on the front of a panel board and turn something on and off?
Not very long.
Worth it.
Yep. Oh, that's right.
Yeah. It's probably faster to do that than it is to don your personal protect all, a 40 cal outfit, right? You could have your daily wear on and throw on a face shield. You can put your gloves on, right? And you can get way outside the arc flash boundary on the other side of the wall. I mean, there's so many different ways you can do this, and we're going to hit it. There's a good example. Adding distance.
Yep. So in that picture there, that's the famous chicken switch on that switch gear. It's on a pistol grip handle, and it's probably got a 30-foot cable on there, and you can see the gentleman standing way back out of the way, being able to operate that pistol grip switch handle without being in front of the switch gear.
And if there was a door around there somewhere, and I know you put him there for
this picture,
for that picture, but if there was a door there, he could go on the other side of that door and operate that switch.
Right. And we have longer cable options, and we have wireless options. Yeah. But you could do it wirelessly.
And this is the front of that piece of equipment?
It's not that exact piece of equipment, but it's the same type of switch. That's electro switch pistol grip, very common in the industry. I think most manufacturers use that at some point. And they're, of course, I'd like to say I think it's probably almost all of our equipment goes on with magnets of some sort.
Yeah.
And so you don't have to modify the switch gear. And that's just a picture there showing someone putting the chicken switch on.
I think we have a video of that too. This is a video.
Yeah. It just shows, it just kind of lines up on the top and tilts on.
Okay, those magnets. And I see the way he's removing those.
Right.
Okay. Those magnets, I bought, I was at one of these events. I don't know if it was the Electrical Safety Workshop. There it goes. It's,
you can see it operating it. Yep. So it's designed to be tilted on and off.
Yeah.
Otherwise, it's pretty hard. And if you try to pull it straight off, you're going to have trouble.
You can't. Yeah.
When you put it on, it's hard to put it straight on and get it to line up right. You normally line up at the top of the switch and you tilt it on like you saw him do in that video right there.
What's special about that magnet? I mean, there are some magnets that you just can't pull off. What is the material?
Yeah, they're neodymium magnets. It's the strongest rare earth magnets that man knows. And those are round ones there. We have different types. Some of them are rectangular, and we're also using a lot of the mag switch magnets now that you'll see in some other pictures that are yellow, and they have a handle where you can actually twist them and they turn off. so that the device comes off a lot easier. I mean, this particular device right here is pretty easy to hold in place because it's not very heavy and it's not putting very much torque on that switch.
Right.
But in the larger devices that you'll see further into the presentation here, sometimes it takes some pretty substantial magnets to hold them on, of which you would not be able to pull off by your hand. You'd have to have some way of turning that magnet on and off. And we use those types of magnets.
Those are electromagnets?
No.
Regular
They're
magnets.
they're neodymium, but there's you'd have to read up on. There's a handle you twist, and I don't know, it inserts something in between some magnets inside the little yellow box, and all of a sudden there's no magnetism in them.
Sweet.
Yeah, and they'll fall off if you turn them off.
Yeah, you gotta hold on to them.
Yeah.
So are what are these? Do you know what they're listed to? Are they listed?
The magnet?
No,
the magnets.
The assembly, like the chicken switch. Is there a UL standard that governs those?
There's not a UL standard for the chicken switches.
No,
we do have some of our equipment that's built in Denton. They have some UL listings on their equipment.
Okay. What do you know what they're listed to? I meant
I do not.
I meant to look at that. That's a side view. It's a little noisy.
That's a side view. You kind of see it operating the switch.
Yeah, I turned the sound off on that one. So that and now these switches are pretty universal, but I could have guessed that there are different model number of the switch itself that the operating mechanism needs to know what model that it's being mounted on, right?
Yeah. This particular one in this picture is a Electro Switch Series 20, which is a really small switch. I think you guys use these on some of your Magnum DS breakers. In this particular model, which is our CSO5, you can see, if you look closely, there's a door right below it that's sticking out probably an inch, and there's another door above it, and it's a very tight space it has to fit into to go on. But we're able to do that with this device. But it fits on that. This particular one only works on Electro Switch Series 20 switch, and it'll work in some pretty tight places with the way it's designed.
Those are the edges of the doors.
Yeah, our CSO1 device, which works on the really common Electro Switch Series 24 switches, probably works. I always tell people probably in 90% of control switches out there, even the GE SB switches. They were physically the same size as the Electro Switch.
Right.
So it fits on, Shalco switches, ABB switch. It fits on a lot of different switches. And fortunately, it fits on the ones that are probably most commonly used. This particular switch in this picture here, I don't want to tell you is real common. I mean, we sell plenty of these throughout the year, but, probably we sell 20 or 30 times as many of the CSO1s as we do this one here, probably.
Okay. Now, if I had a switch in my plant and I wanted to operate it remotely and I wasn't sure, do I go through a catalog, or do I just send a picture of it to CBS
We would ask you to
ArcSafe?
send a picture. Anytime you ask for a quote, we always ask for pictures to go with it, because we're always looking to make sure that you're getting the right product, and we want to make sure there's not like a light that's been mounted next to the switch that's too close and the magnet needs to be there for it to install. So we always ask for pictures, and if you can send us a picture of your switch, we can, it's one of them things we can usually tell you over the phone, whether it's, what we got, and sometimes we'll tell you that there's a nameplate in the way. If you can move that nameplate up 1/8 of an inch, it'll fit.
Do you ever have to modify your, make a custom bracket for a specific application?
We do. We do that all the time. If you have something come up to where it's just not going to fit, we'll design a new frame for it. And we've got multiple ways of doing that. I mean, there's been lots of different designs we've come up with over the years to make it work. Yeah.
So Tamaki Ono has a question. Can this switch on the picture trip? So when you have this, does the handle move when it trips? Or does the trip mechanism happen inside? That would be.
Well, this switch is going to be used on an electrically operated breaker. So, you twist the switch one way and it closes the breaker, and you twist it the other direction and it opens the breaker. So,
Right.
And when you install the chicken switch on there, it's in the neutral position. You have a handheld controller, you hold an enable button, You twist a very similar looking switch on the front of your handheld control box, and it'll move the switch either counterclockwise or clockwise, depending on whether you're opening or closing the breaker.
Right. And it doesn't impede the breaker doing its job of opening for faults or overloads or whatever, because the trip unit is associated with that breaker. This is just a simple, like you say, a contact or a way to tell the breaker to open, as opposed to being the trip mechanism itself. So Tamaki, good question.
Yeah, and this particular picture here, I mean, that switch is designed into that switch gear to be the way to open and close that breaker. If you were not going to use remote switching, you would walk up and put your hands on that switch, and you'd twist it with your hands while you're standing right in front of it.
Right, but that switch doesn't, if I held my hand on that, that doesn't mean the breaker's not going to be able to trip.
Right, correct.
It can still open.
Right.
Can the actuator arm get pulled back to the trip position if the switch when the switch tripped at the same time that the switch is remotely turned on?
The switch?
Yeah, so I think what Tamaki is getting to is, if you, like, say, for example, you're switching it off, or can the actuator arm get pulled back to the trip position if the switch?
Remember, let's say in the when it's straight up and down, let's say in a 6 o'clock position, it's doing nothing. To close the breaker, I believe you turn it counterclockwise.
Right.
To trip it, you turn it clockwise. Well, when you move it to the trip and the breaker trips, that handle, I mean, the breaker is below there in that cubicle. Right. There's nothing that's trying to force that pistol grip handle back to that vertical position again. It's a totally standalone device. Yep. It's not physical, or maybe I should say not mechanically connected to the breaker in any way.
Yes, I think that'll clear it up, because it's like you said, it's not mechanically interlocked with that breaker. It's going to open and close and do whatever it does. That switch is not going to be impacted at all. And what you're doing on with the remote actuation won't have anything to do with the actual tripping of the circuit breaker itself, if you see a fault while you're doing that.
Right. Yeah. Now, what he may be leading to here is, you'll see here further in the presentation, some breakers are not electrically operated, and you got buttons on the front of them you go and push. And we have solutions for those too. But this is for ones that have electrically operated breakers. This is pretty much the same device, except in a wireless version that we're offering now. It's compact. These particular versions come with, they're powered by Milwaukee batteries. We have a deal with Milwaukee that they allow us to use their batteries on our equipment. And so people are really beginning to like those. They're rechargeable.
Yeah, and that's the same batteries that they have on their tools, right?
It is, yeah. Nice. Milwaukee has this thing that they've committed that their upper management, they're not going to change their battery styles for
Great.
years. Yeah, they said, so every tool that they build has to be compatible with this battery. And it brings a lot of benefit to us and our products, especially on products that need a lot of torque, because these new lithium batteries just put out a tremendous amount of energy. But you'll see a lot of our products now coming out with these lithium Milwaukee batteries.
That's beautiful. The wireless is the way. So how far away can I be?
On these particular products here, we build these ones here at our West Virginia location. We advertise 50 feet, depending on the line of sight. I mean, you take them outside, you'll probably find out they go 150, 200 feet, but most people are in a building when they use them.
Right.
So we say 50 feet. They'll easily work in our building here 100 feet apart. But these pictures here are showing devices that go on. We have lots to pick from that go on motor control centers, to actuate motor control centers. And one thing that when we were coming out with these, that we tried to point out, motor control centers usually don't have this goes back to your risk severity thing.
Yeah.
Don't have as much arc flash energy typically as maybe the substation breakers do.
Mm-hmm.
I mean, they can, but probably as a whole, they probably don't. But typically you find out you operate MCCs a lot more than what you operate your substation breakers. So, the risk goes up because the amount of exposure you have goes up.
Right.
Typically a lot more switching with with motor control centers.
Absolutely. And there's a fusible. I like this. This is an interesting one. And that where that bottom piece is down here, that's where you would tie in your umbilical cord, right?
Correct. Right. So this is the device that operates this fusible switch. You can see the magnet on the side there, the yellow magnets I mentioned with a kind of a T handle on it.
Oh yeah.
Yep, you rotate that 180 degrees and it turns the magnet off and allows you to easily remove that.
It's called magic.
Yeah.
And there's no configuration. I mean, I would have wondered how the heck are you going to do this? And when you look at it, I mean, it's relatively simple, but it's a complicated piece of equipment. But the concept of how do you operate that handle and you get the right radius,
Right.
and all that, and you've got a lot of metal there, so the magnets work perfectly.
Right. Right.
Big metal gray boxes are now plastic boxes. What do you do with plastic boxes?
Well, I don't know that someone in Texas would have to speak if we've ever done one of these on a plastic box. I will tell you
Yeah.
that on the chicken switches, every once in a while you'll run into a or a pistol grip switch mounted in plastic or maybe even in stainless.
Okay.
And we make a variety of metal plates that you can take the front escutcheon plate off your pistol grip switch and put this plate on and sandwich it between it and
Yeah.
the plate, put it back together, and it down each side of the switch, it gives a place for the magnet to grab a hold of.
Gotcha.
We also have a new product along those same lines that we just come out with that actually has a bracket that you put behind there with some latches where you actually latch the chicken switch on.
Okay.
And we're finding that to work in not only in places where you don't have metal that you can get a hold or magnetic metal that you can get a hold of, but also in places that don't have very much space on each side of the switch. You know,
Right.
we only need like a quarter of an inch on each side of the switch to get that to work.
Right. Now tell me about this one.
So we've got products that allow you to turn these disconnect switches on pad mount transformers, oil filled transformers.
Yep.
And we're seeing more of a demand for that here in recent years. Companies wanting to be able to do that.
Interesting. And these are your outside pad mounted type of switches, right? Or
Yeah,
transformers.
the outside pad mount transformers. You know, it could be something you find behind a Walmart
Yeah.
or in a subdivision or yeah.
And I like the carrying case. You put it all nice in there, and they can throw that on the truck and go out to the job site.
Right.
And molded case circuit breakers.
Yeah, we've got a bunch of solutions for molded case circuit breakers. Of course, those are probably some of the tougher solutions because there's so many different mounting configurations.
Yes. And they're tight spaces too.
Tight spaces. They take a lot of force to move some of those handles if it's a very big breaker.
Yes.
And, so again, we need pictures of what you have, and but we do a lot of molded case circuit breaker work.
Special orders don't upset us, right?
Right. So here's an example we were talking about of pushing buttons.
Yeah.
That's a SPB breaker on the left, and you can see the red and green button in there. That device will reach out and push those buttons remotely.
Okay.
And then the picture on the right is our DS10 model that we've had out for many, many years that will push the buttons. That fits a DS breaker, your Westinghouse DS breaker.
Right.
And it'll push the trip and close buttons. You can't really see what's happening there because it's on the bottom side of that sled. And it's all held on with magnets. You just grab that handle and tug it a little bit and it pops right off. And we've sold a lot of those over the years. I mean, that's, the good thing about those DS breakers, according to my research, I think Westinghouse came out with those around 1969.
Wow.
And the front of that breaker, that area where that goes on, didn't change no matter whether you had an 800 amp or a 5,000 amp breaker. They were the same on all of them.
Wow.
Dimensionally. So this thing fits on all those breakers. I think that was Eaton's standard breaker up until 2006, maybe.
Yeah, when we came out with the Magnum.
Then you come out with the Magnum.
Yep.
And so that was made. And then you guys also sold those to Square D.
Yeah.
And some of them say Square D on them. There's just, we'd like to know how many of those breakers are out there, but there's a lot of those out there. They were really good breakers.
Yeah. And and you're not tied to any specific manufacturer because you guys can make switches for just about any manufacturer, breaker, and vintage that's out there, right? I mean,
correct. That's really our market when you get down to it.
Yeah.
the legacy stuff for sure. I mean, that's where,
Absolutely.
I mean, even you guys, I mean, you'll make solutions for a Magnum DS, which is a breaker that you sell today,
Hmm.
but I don't think from what I've seen, you guys show much interest in going back and making stuff for old breakers you no longer make anymore.
And and you and I had that discussion before. We were talking about like about competitive nature of the business and whatnot. But it's really we make the big great boxes, we make the breakers. That's our wheelhouse. And do we have these ancillary devices? Yeah, we do. But am I in that business like you are with regard to going back to these older breakers? No, I mean, because I'm working on the next thing coming out. I'm working on the next big breakers coming out. We just did power defense breakers. I'm worried about all these other things associated with it. So having organizations like you guys out there doing this is we all work together from a safety perspective, and that's one of the things our common platform is. And Pringles, I mean, I've heard a lot of people
Yeah.
talk about opening a Pringle and doing that in front of that Pringle switch, and they get nervous about it because I mean that's a big switch. There's a lot of energy
Yeah.
that's behind that, and having something that can mount. This is the first. I didn't realize you guys made something for a Pringle switch
Yeah.
till today.
Yeah. And we make stuff for some pretty good size, disconnects, outdoor types disconnect switches that take a lot of force to move the handle.
Yeah, because that's what I'm amazed is there's a lot of force that's required, and
Right.
think about the motor and the way you have to actuate it. It's an engineering challenge, more of a mechanical engineering challenge than
It is.
electrical.
Yeah. Yeah. I'm more of a mechanical engineer now than what I used to.
I
That's
know.
what I tell people all the time.
I
I live in the electrical world, but my issues I have every day are mechanical.
Yeah, when I
Yeah.
first started working with Eaton, I came from an architectural engineering firm, and I was, it was like Westinghouse Eaton. It was '96, so they had just gone through the acquisition and whatnot. And I was really nervous because I'm like, I'm going to be with all of these really good electrical engineers, and I know, how we get. We'll challenge each other, from a technical perspective. And I'm talking to people, and I'm like, well, what's your degree at Eaton? And they were like, I'm a mechanical engineer. Like, oh, I talked to another engineer. What's your background? Mechanical engineering. I'm like, man, there's a lot of mechanical. And somebody like looked at me and goes, well, Tom, did you ever look inside of a breaker? It's a very mechanical
So
device.
mechanical.
Same here.
Yep.
Now remote racking, that's another, in the medium voltage. Now this is our solution, and we've got other pictures of to show the breadth of all of that. Eraser, I don't know how to undo that. But it's turning, it's in slow motion right now, but how do you, geez. I don't know how to get out of that mode. Whoa. Where you are fast viewed. Anyway, I put the pointer on and this on, and now I can't get rid of it. So, but this is pulling things off. You can see the shutters actuate in the background. I have a side shot of it as well. When you think about these types of devices, there's a lot going on inside of that piece of equipment that if something goes wrong, if there's a problem because of it wasn't maintained well enough or whatnot, you just want to get outside and remotely rack these large power breakers and medium voltage. I wouldn't want to be in the room when that thing goes off, right? I mean, it's just that's a high, it's a very intense situation to be in. And then this one here was just a
This is an example of integral racking,
right.
where you all make this product that actually, I think it's on your VCP breakers that
Yep.
it's built right in. The racking's built right into the breaker.
Yep.
The remote racking is.
Yeah.
So that's another type of solution.
Yeah, so this was sort of a compilation. We're going to talk about the motor control centers and whatnot a little bit later. Here this is a good lineup of I'm not sure is that Allen Bradley? No, GE.
Yeah. Looks like GE. Yep.
And now
so I need to speak on this one. I think you go to that next slide where it shows a picture of it. So when it comes to racking, I mean, this is what some would call a universal racking device. It can rack a lot of different breakers. The big differences is the the torque that's required and the tools that's required on the end of it to engage your breaker. You can see the motor can be moved up and down. It's on wheels. It can be rolled around. Can be used on a lot of different breakers. And I think here in a minute, you're going to see we also have a lot of single-use type tools where it's a device designed to work on a specific breaker. And just wanted to talk a little bit about the differences in those. I mean, each one has its pros and cons. You know, the big one that you saw in the previous slide is, you know, one of the pros it has is it works on a lot of different stuff. Some of the cons it has is it is more difficult to move around. I mean, if you're trying to use this in multiple substations, maybe in your facility, you know, it's not as easy to move around as a single-use device is. And there's more parts and pieces of this, so it's a little bit more complicated sometimes to get everything, you know, the right tools on it and get it all engaged and hooked up. The single-use tool, you can go back to that next slide. There's some examples on there, and I'm sorry those are so small, but they're typically handheld. They're able to be installed right on the front of the breaker, and you know, they're made. I mean, they work very well. I mean, again, the pros and cons of those is that pros is they're fairly lightweight. They're easy to move around. They're easy to take between substations. They're typically easier to install. The cons is probably really the only con that it has is that you know, it's made for a specific breaker. That one on the left there is made for a Magnum DS breaker. That's all that's going to work on.
Right.
The one on the right that's a VCP breaker that only works on a VCP breaker.
And that's
you've got one there.
That's the Magnum there.
Yep. That's Eaton's Magnum.
So this product here works on the same breaker that this product works on, right?
Correct.
And you could see the approach. You know, this design here is a frame. This one over here, I'm sure this is heavier than this one. Okay,
probably so. Yep.
Absolutely, and there's an advantage to your solution over this solution. And and even though we manufacture this and it goes around that Magnum breaker, and we pay attention to the even those that are on those. What do you call it? The arc resistant equipment, because they have that rubber gasket in there. You know, this just really gives you a picture that there's more ways to approach the problem of trying to do that. So,
and you'll find that I'm not showing it in these pictures right here, but on that Magnum DS breaker, I mean, there's a CBS ArcSafe has two solutions for that. There's the one you see in the picture, and then there's also a version that we make here in West Virginia that's of a different concept. That so, and a lot of times we can offer you more than one solution. It depends which one you like the best. You know, which one you feel the best about. Yep. And like Tom said, there's just multiple ways you can go at tackling these. And,
absolutely.
You know, when CBS ArcSafe bought us, I mean, that time before that we were kind of competing with them, and now when they bought us, I mean, we brought a lot of the same products to the table they were already making.
Right.
And we've not stopped making any of those products. We just offer two solutions, and
sure,
you know, the customer pick which one they want.
Yeah, because there's a lot of preference. There's a lot of personal preference and whatnot. Because especially if you're familiar, like if I'm familiar with the chicken switch and I've bought those in the past, and my guys are trained on that, I want to continue buying that same type of solution. I mean, that's obvious, you know. Now this is that same product that we looked at before.
Yeah, this is the extraction style. So the other ones were rotary, where you're turning a screw to pull the breaker out. This is one where it actually pulls the breaker out. Yeah.
Okay, gotcha.
Yep.
Yeah. Okay. And I was wondering what's the blue arm with the T?
Well, that's holding it from moving while it's pulling. You see it's pushing it on the right picture where it's kind of wedged against the frame on the bottom so that it can pull the breaker out.
And then these are more. This is another
similar, except for that's MCC buckets.
Ah, cool. Okay. Right. Yeah. Yeah, and MCC. So, and then there's integral too. I mean, what's this one here? That's still an MCC?
Yeah. So, you know, now you've got MCCs coming out that are like closed door racking, where there's some method to rack the bucket off the MCC without just grabbing a hold of it and pulling on it. And these are two solutions. We have a solution for the Allen Bradley Secure Connect we've got a solution for the square D CDR units, and I think you had the next pick, didn't you? You had a
I
pick.
think I
You
have.
guys had
Yeah.
the
You know what I did? Hold on.
I think it was mixed in that video you were showing earlier.
Yeah, you might be right. And
That was a flash guard, I think maybe it's called.
yeah, we got the FlashGuard MCC, and it and the way we built that. In fact, I just I did. Here it is. Arc Flash MCC. I think this is it. Yeah. So if you look at how we constructed the FlashGuard MCC, we have that bus in the back. We got shutters, and then the way the bucket is constructed, there's a thing on the top that gives you that indication of it's going in, and then those are the stabs that go on to the actual bus, which we just saw the shutters that are in place with the insulating material. That's that red color phenolic or whatever it is. And then what we do is we take the front. You have your port, and then you have to make sure it's in the off position, because you'll see in this short video where if he turns that switch in the on position, watch the little door in the middle. You can't plug anything in there to rack it off if it's on, so you have to have it in an off position. And then there's indicators on either side that tells you the level of engagement on the bus. And let me do this. So this, because it's a widescreen type of thing, as you as it pulls off of the bus, those indicators on either side will tell you how far and that you're coming off of the bus. And then when you're in they call it test mode, right? Mm-hmm. And you guys have products that'll do the same type of deal, just like you just showed with magnets, etc. Where this will start to pull that off the bus, and you'll watch the indicator go from red to green. And there is a test condition, and I think there's a portion of this where if you look at the side of the bucket, it'll tell you when you pull it out to a certain point, when you're off the bus, but you're still energized with, say, 120 volts, and you can test things. And then you pull it out further and you're completely disengaged. So these are from a technology perspective, it's just absolutely amazing. It's an arc resistant type of environment, and we are able to do things. And this one here shows you as he's withdrawing it, just with a drill. I mean, and that's basically. I knew I had a little, at least a short clip on that one. But the whole thought process is, can we get those guys out, keep that dead front in, and then if you add distance, you don't have to use the drill in front of you. You can still be outside of the arc flash boundary, assuming that even though it's an arc resistant piece of equipment, and I can sit down and say you can stand in front of it, do that. If there's an explosion, it's going to contain it. I'd still feel more comfortable getting outside if you got the tools. Now, what's this?
Right. So this is another way to get outside the arc flash boundary. This is a facility I used to work at. We were big at that time. This is probably in the 90s, of putting mimic panels on the end of the switchgear, or at least somewhere else in the room, or in some cases, place I've worked, we've actually installed them outside in a cabinet. But you can install the pistol grip switches at the end instead of in the front of the switchgear. And like in this example here, there are no switches in the front, so it's not. This is a true engineering control situation. There's no way the guy can bypass an administrative control and operate that breaker. He's got to come down here to the end. Downsides, the pros and cons here. Pros is it works well because the guy doesn't have any choice. Cons are, these installations, you got to be careful because it's pretty easy to get your hand on the wrong handle when it comes time to open a breaker. So you're always worried about, you're getting ready to go into a shutdown, you're doing switching.
Yep.
Did he grab the wrong handle? And
yep.
So, you might want to think, if you have one of these, you might want to think about, how do you control that? Do you, I can remember us standing there, we always had two people looking at it. One guy lays his hand on it, the other guy checks the label, says, yep, that's the one I want.
Right.
And then he twists it. Yeah. How do you control that? Maybe you paint them different colors to match the front of the breaker, maybe, or something. Yeah.
Well, but like you say, even if you try to do that, you're on this side, you're not looking at the face of the breaker. So if you're going to have colors, somebody has to look at the face to say, Is it blue? Yeah, I'm looking at the blue cubicle. Okay, we're okay. But then you could just simply say, does it say 1AB? Yeah, I'm not looking at 1AB. So, but I
Right.
understand now, and I get what you're saying. That could be a challenge. Just making sure
Yeah.
you've got the right. And there's always lookalike equipment. There's always those types of issues that we hear in accidents.
Right.
Yeah, good point. What's this one?
So this, yeah, it's this switcher relay example that a friend of mine from the plant sent me to use because we were talking about this presentation, and we were talking a little bit about using time delay
Hmm?
control switches. I believe um, Electro Switch makes one. We don't have a picture of one here, but this is a switcher relay that can actually has a trip and close button built into it, and those relays can be programmed. I've not personally done it myself, but I know they can be programmed. He was telling me this particular one here, you got to hold the button in for, and they've programmed it this way. This isn't like
Hmm.
a default thing. You got to hold the button. If you want to close the breaker, you hold the button for 7 seconds, at which time a 10-second delay will start. So they didn't want a situation where a guy accidentally bumps the button
Right.
by and it closes, it starts to close the breaker. So you push the button, you hold it for 7 seconds. I think a light or something changes color to tell you that the 10-second delay started. Then you get out of the way and you
Right.
move,
Right.
you go. And so there's some applications where that works good. You can't put
Firecracker.
it out.
It's
Yeah.
it's that magnum firecracker that you lit and ran away from, and then it didn't go off, and then somebody's got to go over and maybe kick it or something, you
Yeah.
know. But
Right.
yeah, I mean that's
Yeah.
if it doesn't open or if it doesn't close, then what do you do? What state
Yeah.
is it in, and all that jazz. So I guess you have
That's
a
not, yeah, that's not saying it's a bad solution. I mean, all
right.
these solutions have pros and cons, but it's just something to think about when you're trying to decide
Absolutely.
what direction you want to go.
Yeah,
Um,
but I like the concept of
yeah, a lot of
you
people are
set
using
that
them.
trigger, get it out
Yeah,
of that, and then let it do its job, and then you come back again.
right.
Unique way to approach the situation. And Ryan Jackson says that the Eaton's custom shop can paint can make those doors different colors for you, Russ, if you want.
All
We
right.
can make them any color. We can just go down through the spectrum. You know, I would say pick a nice like if you want the blue tones, the red
Hmm.
tones, the green tones. We can do all of that.
All right.
Now, I personally I love this one. When I saw this slide, and what I love about this is the implementation of a camera because there is, you know, if I'm outside the door and I'm on the other side of the wall, I still want to see what's going on and I might want to see up close on what's going on. And this gives you the ability to do that.
Right. So there's two different things shown here. On the left is a system that we sell, is just a camera and a remote monitor. That camera is actually mounted on a flexible, I don't know what you call it, pipe.
Yeah.
You know, it's a
You can
snake that you can bend in
bend
all
it.
different shapes. And, you know, you can, and maybe you're not even doing switching. Maybe you're doing something else that where you'd like to be able to watch it from a distance or maybe watch
Sure.
it over time.
Yeah.
And you can attach that to your switchgear door. You can bend that around to point it at whatever you want to point it at and get out of the way. I know we make this product. I haven't personally used it. I know that there's a. I was asking my guys down there the other day about it. The you know, it's offered. You got an SD card you can put in there where you can record.
Nice.
Um, so maybe you could use it as a cheap data recorder. You know, point it at an amp meter before you start that motor. You want to see what
Yeah.
the amperage does as it comes up to speed. You know, you get a little recording of it. So
Absolutely.
it can be used for other things besides remote switching or remote racking.
Yeah.
Um,
I can, you know
but
what, you could probably like mount that to your back and then have that like have it be a mobile cam where you can just like
yeah,
walk around the plant, you know?
we'll do that in your next presentation.
Okay. Yeah,
Put
that
that
sounds
on you.
yeah, we'll put it on Jake or Maggie. You know, we'll
Okay.
strap it to their back, let them run around the backyard, be a doggy cam.
Yeah. Yeah. And then the one on the right, that's a racking unit, a single use racking unit. And that's built into, actually built right into the rack unit. So when you plug it in, you don't have any choice but to look at the position indicator. And it's hard to see in that picture, but it's viewing the position indicator on the front of that breaker. It also displays some additional data up the right-hand side. It displays the approximate torque that it's that it's putting out to rack that breaker.
Oh, I
And it
see it.
kind of gives you a little bit of feedback while it's racking. You can see when it hits the bus, you'll see that torque go way up while it's trying to pull it up onto the bus, and then it'll kind of settle back down again. So the idea there was to give you a little bit of feedback. Normally when you're cranking them in there by hand, you can tell, you can
Yeah.
feel that, that, man, I'm coming up on the bus with it right now.
Yep.
And so the intent of that was to give you a little bit of feedback that, going up onto the bus, or maybe I've come off the bus. If I'm coming out, you can see that torque just fall off.
Right. In
Yeah.
fact,
So it's a little
uh,
bar chart, little bar graphs, what that is.
yeah, on
Go ahead.
on our little operator, I call it the robot, but that little robot that does the medium voltage stuff, which we had that little video. When I was up at our experience center working with that, Dan Carnevale was telling me that that you tell that device what breaker you have, model and whatnot, and it knows the signatures of the torque. It knows
Mm-hmm.
that, okay, if it's fully racked in, it should see this torque for this much time, and then it should tail off. So it knows like when to stop in that process, because I've seen this torque too long, and I'm not going to just keep trying to ram it home. I'm going to stop and say, you've got something going on. So the torque is a very important piece of this puzzle. So
Yeah.
you can pretty much, like
Yeah.
you said, tell when you're on that bus and when you're coming off, or when you're just going on.
Right.
Now that picture that's on there, that's the actual picture of the window right there.
Right. Right.
I like that. I'm just sold on cameras. I really am. It's just the more, in fact, there's these little cameras that you can buy, like on a thing, like you do engine work on cars and stuff like that, or plumbers and whatnot. They'll put those, instead of trying to figure things out by feel, just send a camera down there and take a look
Yep.
at it. It's amazing what you can
Yep.
do with a camera. And then there's the remote, which I'm more familiar with. This is when I came to Eaton back in '96. My start day was January 2nd, 1996, and it was a holiday. Miller Brown was my my boss, and he sent me an email. I said, "Hey Tom, don't come in on January 2nd because it's a holiday." And at the time I had just moved home, and I told my dad, I said, my first day's a holiday. He's like, "Man, that's a good company."
Yeah.
He says, "Yeah, you're going to do well there." He was right. He was right.
Yeah.
So, but what I was working on, and this is '96, for major automotive and resin facilities, they had we used Wonderware and Iconics, and we had all of our circuit breakers out there that would communicate, and we would create HMIs. We would create one-line diagrams, plan views, so you could look at the overall view of the facility and zoom in on all the different rooms and see all of the overcurrent devices that were feeding current to whatever it is. And in a lot of cases, it was like, say it was an automotive facility, they knew they were using it for how much energy does it cost them to make, say, a transmission or a vehicle, and they knew per car or per transmission how much energy it cost, and then they would put in profiles. But then in some cases, what they didn't realize is they also had the ability to open a device remotely from a computer in an office, where they can sit down and say, grab a walkie-talkie with the electrician and say, okay, you're standing in front, okay, we're going to open up 4AB, listen for it to open. They can hit it, and then they can say, okay, we heard it operate, and now they can go in, and what you've done is you've pulled back that layers of the onion to where he's still going to suit up, or she's going to suit up for verifying absence of voltage, but you have a higher confidence level that you've de-energized the application and established an electrically safe work condition. But then, to your point earlier about everything has pros and cons, right? Cybersecurity starts coming into play with regard to things that can communicate, and you can control who has the password for that, who's sitting in front of that computer. All of that good stuff comes into control whenever you start to network. I know we had challenges at we had a Carnegie Mellon and Pitt and Penn State. Students love to hack into the system.
Oh yeah.
And they were, and it was all in fun back then. I mean,
Yeah.
I never felt like, and none of the facilities I was in felt that, hey, these guys are going to try to open a breaker or something. It was more, hey, they deleted the data or whatever, right? Not the pipeline. Well, that's right. So Frederick, that's the thing. You've got to think about these things. I mean, the pipeline is like is just a it's like, what do they call those smelling salts? Like, whoa, yeah, that's something I got to think about.
Mhm.
So everything comes with its challenges, but the end goal really is to get the electrical worker outside of that arc flash boundary for whatever reason, or outside of the room, because it might not be that piece of equipment you're worried about. It might be something else you're worried about. A lot of different reasons to get somebody out in front of a piece of equipment.
Yep.
We took an hour program into an hour and a half.
I see that.
That's not bad.
Yeah.
And we still have Frederick, who was here with us in the beginning.
Yeah.
And we still have, look, and Robert says azure blue or heavenly pink.
Oh, I got all.
Okay, so Ryan Jackson says, if we have a cyber attack on a breaker, do people panic and go buy a bunch of breakers like they did gas? You know what? Ryan, that's not a bad. You know what? If there's any marketing people watching this, I mean, this is man, oh day, that's just wrong. That's just wrong. Jeez, oh man. But you never know why people are at the gas station with those red containers. And the other day when this happened, I was at the gas station just putting gas in my vehicle, and I saw somebody I saw the back of a truck, and there were all of these red cans. And I'm sitting there at the gas pump, and I'm thinking, oh my gosh, come on, you got to be kidding me. He's got all of these gas cans he's filling up. And I'm thinking, man, it's just unbelievable. And I went into the store, and on the way I looked, and it was lawn care. He was a lawn care company. Yeah. That's why he was there. But you always reserve judgment. Judge not, yes, ye be judged. And it could, but to Ryan's point, it could be a new Eaton business model or a new CBS ArcSafe business model. You never know.
Yeah.
But so we covered establishing the arc flash boundary. We know that there's two methods to do that. You calculate arc flash, or you're using the table method. We also understand, we covered the fact that you really having a high confidence that you meet all these criteria around maintenance, being installed correctly. There's always that opportunity for doubt on whether or not those big gray boxes, like the one behind me, are going to function the way they're designed. And then we went through all the different methods to get away from the piece of equipment. And if you bought it, use it, regardless of whether or not it's if I've got the dead fronts on, I've got arc resistant equipment, and I've got to operate a breaker. I mean, you might say, boy, Tom, that's an overkill, because you've got arc resistant equipment and it's in great shape, and you still put a chicken switch on it. Give me a break. I mean, what are you, chicken? Right? Well, yeah, I'm just going to get out of that zone. It makes sense. You got it there, use it. And we saw in the videos, it's not hard. Once you have that piece of equipment, if it's a magnet, boom, it clicks right on the front of the equipment. You walk away, you press a button. You don't have to worry about personal protective equipment. Just use it. Do you see a facility, like, have you experienced the facility buying more? Like, if I had nothing but, I don't know anybody who buys anything other than Eaton equipment. So let's say that I had nothing but Magnum circuit breakers in my facility. Would I only need one for my entire facility, or would it behoove me to have more than one of those?
Well, it probably depends on, how spread out your substations are, how much work you could possibly have going on at one time. It wouldn't hurt to have two in case you're having trouble with one or something comes up, like that. That I mean, it's
Hmm.
really each individual location has to decide that. Looking at their operation and what they're doing.
Yeah, and to your point,
Yeah.
if you have multiple, like a campus style,
Right.
because I always said, I wrote an article one time on this because I was in my basement looking for something, and I typically have my glasses on, and for some reason I didn't have my glasses on, and as I was, when you're looking for things, you're like, I should go get my glasses for other reasons other than safety. And I didn't go upstairs and get my glasses, and I ended up pulling dust come out, hit me in the face, and I ended up with some a little piece of chip. It was like a little black piece of plastic that was up under my lid. I went to two eye doctors to figure out how to get it out of there, and the second one finally, ferreted it out. But
Mm.
availability is increases the likelihood of usage.
Exactly. Right. Exactly. And that was a point I was just getting ready to bring up, and that that universal unit rack unit we looked at
Hmm.
is more difficult to move around, and it's also more expensive in this than the single use units.
Right.
And we always had in mind when we were designing and building these things that if you had Magnum DS breakers in a substation, you would have one of those racking units in that substation ready for someone to use. Because the harder you make it for them to have to, if they got to go a mile away to the other end of the plant and load that on a truck and bring it down, they're less likely to use it
Yeah.
than if you make it readily available there, which is the point you were just trying to make.
Yeah, that's exactly right. I mean, so if I have one lineup of equipment and in one room, all I need is and put it in that room, right? I mean, you put it in
Right.
a closet there, put it mount it on a shelf, put it so it's visible, right? But if I have a campus and I have multiple rooms, I mean, putting one of those in each of those rooms, and I always say regardless of the cost, but I understand cost comes into this role, but you've got to look at what is the cost of the solution that you're going to put in. It's like insurance. How much if somebody doesn't use it, if it's not available and they have an accident, that's very expensive in downtime and hospital, if not legal issues, all this other good stuff, right? So it's just worth having something like that for the worker, and there's so many different things that we could provide as an industry for the electrical worker that it's silly to, and that's why I go, if I go back to, I really do, I really like your, you know it's the arc flash injuries not only are avoidable but unacceptable in today's workplace. We've got the
Mhm.
technologies for that.
Right.
And I talk about it with regard to GFCIs. I always tell people that it's absolutely ridiculous that somebody could be in their house and die from electrocution when we have very inexpensive, relatively inexpensive technologies to prevent that or reduce the likelihood of that.
Mhm.
Right. So, and these technologies are readily available. And to your point, the equipment, regardless of the vintage. I know you and I talked about this when we were talking. I don't know if it was the Magnum or whatever it was. And you were like, boy, you guys changed something. I'd love to get up to the experience center and take a look at that because we
Right.
were trying to figure out,
Yes.
the to make something for it. And then Robert from Omaha, he's, what does your maintenance breakers require from exercising them? You're right. So even 70B will tell you have to exercise these circuit breakers every so often. And there's a table, and it's really dependent upon the conditions and all of those other parameters. And if you can sit down and say, I have to operate this breaker due to, from a maintenance perspective, I'd rather operate it with a device remotely as opposed to standing in front of it.
Mm.
It just makes sense to me, right? And it's a good investment and something that both our companies try to bring solutions to the table for the electrical worker, and we do, and others do as well. So the good thing is that that people like CBS ArcSafe they see an opportunity in electrical safety. If it's not for innovation and innovative thinkers and organizations to say, how do we get people to use this equipment? How do we get people out of these arc flash boundaries and bring technology to the table? Then we're left to our archaic ways. So what do you want to say? What's the parting remarks, Russ? What's the takeaways?
Well, I want to thank you for the opportunity. I want to thank everyone that showed up and has listened in on this. It looks like everyone's hanging in here, doesn't it?
Yeah, we usually get
Yeah.
good. And then so they hang in there. So you got Robert and David Engelhart from out of Florida, Frederick. I see a couple new names in here that I've not seen before. We got Japan on the house. So we're international. So let me ask you a question, Russ. Do you guys make solutions for overseas, for international type of products?
Yeah, we're getting drifting into that a little bit more. And I think part of that's demand, over in Europe area and stuff. It just doesn't seem like they don't have any laws in place, or they're not recognizing it as quickly as what we have over here.
They don't have
Although
lawyers.
yeah, but we are finding equipment that is showing up, European type equipment that is showing up like in wind farms over here,
Right.
that they're needing solutions for. So we've been building some solutions for that type of equipment. We don't necessarily see a lot of sales over there for that equipment, but for the equipment that's showing up in the U.S. and some stuff. I mean, there is a lot of stuff that goes out of the country, but a lot of it goes to an American company that's got a location outside the company also.
Gotcha.
They recognize that if a life is important here in this country, it's important no matter where they're at in the world.
Yeah, absolutely right. Yeah, and you're like the DuPonts of the world and those types of
Right.
individuals. They have that global perspective. But if Tamaki Ono said, "Hey, I've got this job site," and Tamaki's out of Japan, I mean, does that say, well, hey, it's not something we do? But if they send pictures, that's a market?
I mean, we would work with them on to try to find a solution for whatever they have.
Yeah.
Sure would.
Yeah. So, and that's another, I guess, another message, because remember, this video is going to be on my YouTube channel. It's on LinkedIn, on Facebook, and those 3 platforms. It will be on YouTube until CBS or you guys say, "Hey, Tom, let's take it down," right? But it's fine. It's up there for as long as or YouTube lets me keep it up there. I'm not political. We don't get political on this channel at all. We don't cuss. We don't swear, and so there's no reason for anybody to tell it take it down. And so anybody can be viewing this after the fact and know that they can reach out to you. They can reach out to me. Our contact information. So CBS ArcSafe, I mean, it's just, what is it? CBSArcSafe.com or?
Correct. Yes, sir.
Yeah. So www. There's only 3 W's, CBSArcSafe.com. Just want to make sure it works. Yep. CBS ArcSafe, and everybody knows Eaton.com, or they can send me an email, contact me on my channel. I will get Russ,
I'm going to send you some links to put on your video like you asked for.
Yeah. Perfect. Yeah, we'll put some links down the bottom on the YouTube and on my LinkedIn. I learned today that I can't put a lot of links, because I had like 12 links to different videos I found online, and on my LinkedIn description there's a limit, and there's also a limit on YouTube, but they give me a lot more latitude. So, but also I'll put it on my website on my thomasdimitrovich.com as well, and that way. Always sharing information, and we're all working together to increase safety, which that's what I love about it. And I'm always looking for reasons to work with Russ Safreed, because you and your brother taught me how to weld.
No.
So
you've done well. I'm impressed.
Hey, it's fun, man. I'm having a blast.
You're painting too. Yeah.
Yeah, and we had breakfast the other day. I showed you my paint job, but it was raining, so that was a little bit of a. I guess it was distorted a little bit, so it is what it is.
Yeah.
All right, everybody. I don't see any other questions. Thanks, everybody, for tuning in. Thank you, Russ, for joining me. I enjoyed our discussion. And Tamaki and Ryan and Robert and everybody else who joined in, Frederick, thanks for joining in. I appreciate the engagement and the questions. So thanks. Thank you, Russ, for everything you do for the electrical industry and safety, brother. And
Thank you.
thanks to CBS ArcSafe for help make this happen. And then David Rodriguez too. So we're going to sign off, everybody. So take care, stay safe. God bless. And remember, please stay, what do we say? Healthy. So we're going to sign off, and you're going to hang on there, Russ, afterwards. But okay, everybody, we're going to shut down this panel. Electrical time. Tom and Russ, great information. Thanks. Steve Cavalaris. And Steve was there for the whole time, too. Look at that. An hour and 45 minutes. God bless him. Listen to us ramble. All
Said
right.
you didn't need 2 hours, remember?
That's right. We didn't need 2 hours. Oh, my goodness. All right. Thanks, everybody. Take care.